Hello everyone, I'm Xinhong Wang from Shanghai Jiao Tong University. Today I want to introduce a very hot machine learning model, graph neural network, and talk about how to deploy it online via graph database system. And this work is done by Shanghai Jiao Tong University and Ant Graph together. I hope you can enjoy this talk. And graph struct data have a lot of applications, such as we can model the relationship in social network, and we can forecast the traffic flow on the road network. And the other applications include drugs, knowledge graph, and chemistry and physics. So graph data provide a more expressive way to describe the relationship in the nature or the graph society. Human society. So the GNN, what does GNN do? GNN, the task of GNN is so simple. First we put a graph into a GNN, and the GNN will output the embeddings of each node. For instance, for instance, if we have the embedding of V4 and V8, the embedding is different, so we can distinguish them by the different embeddings. Because for example, the V8 is a blue one, the V4 is a red one. But the question is, how do we obtain the node embeddings? Here is the simplest GNN model that if we want to compute the embedding of V1, we need to aggregate the information from their neighborhoods V3, V4, V5, and V8. And we use some aggregation functions or neural network modules to update the V1's embedding layer by layer, step by step. For example, we can aggregate the one hop neighbors to update V1, and we use the two hop neighbors to update V1. We need to three hop neighbors or the entire graph to update V1. So although the GNN provide a promising way to capture the data platforms, data patterns, however, this module are designed to deal with the static graph, but the graph data in real world are static. For example, in social media, the users always transfer their interest to other entities. In economic network, users always transfer their money to a new company or a new bank. So in the dynamic graph, if a node change, the embeddings of the neighbor should be updated. But if the change or the interactions happen so fast, the graph database might be overloaded. So to address this problem, we put our models called asynchronous GNN. Let me explain this. In the traditional GNN or synchronous GNN, if we want to check an interaction is fraud or not, we need to query their one hop neighbors and use their one hop neighbor to query the two hop neighbors, and then get the final node embedding to make the final decisions if it's freed or not freed, in fraud or not fraud. But it's a waste of time. It's lost to time if we don't we can make the decision immediately. In our models, asynchronous GNN, we don't need to query the neighbors before we get the final decision. We just use the last update embeddings to have a final decision, and we propagate the information of their interactions to other neighbors. It's something like a water wave. If a water drop into a pool, and the water wave will spin into to another place. Compared with other advanced method, we have significant speed improvements with competitive performance. Thanks a lot.